and has a potential of 0.8 million units per annum. And total value-wise, it is approximately 4,500 crores. Uh, although we have so much of a potential, but we are highly dependent on importing these brands from primarily China, Taiwan, Korea, Finland, Germany, and Japan. So if you see the way the drives are being introduced in the market from 60s, or primarily it used to be a very, very large system, transformer-based control, then a cycloconverter method. Then there are two parallel technology came as a voltage fed and a current fed type. Then thyristors have come, then transistors, UJTs have came in. Uh, until the intervention of an IGBT-based technology, it changed a lot. Because in the IGBT, THD is very low, higher switching frequency and better response. These are the reasons IGBT has dominated for the last 25 years. IGBTs also have evolved. Nowadays, it comes as a packed model, integrated power model, means the rectifier and inverter section both are in a single pack. And it is becoming compact, effective, more efficient, more thermal handling capability. Uh, there is a new parallel technology coming as an IGCT, which I will show you some pictures in the future. Then again, on the application side, the IGBTs with the region options, the active front end, drives have become modular. Then common DC solution, AC to AC, which is a direct converter, rectifierless designs. So these are the drives have been coming. So there is a brand called Yaskawa who introduced the rectifierless design, which is called Matrix. So direct AC to AC drive. Now many other companies are adopting to this. Finally, generally the industrial drives are 6 pulse. Where there are some harmonic issues, and then where the industry needs a very high-end power solution, they go for a 12 pulse rectifiers in a low voltage. In a medium voltage, by default, it is 12 pulse, 18 pulse, 24 pulse. Request the members to please be on it so that the others are able to hear. So what are the terminologies? You hear drives, AC drives, inverter drives, variable speed drives, adjustable speed drives, frequency converters, variable frequency drives. These are all the common terminologies which you hear from a different industry. So some industry calls it the frequency converters, some call it the inverters, and as simple as drives. But the actual terminology is the right terminology is variable voltage, variable frequency drives. Because we are not just saying changing the frequency, we are also changing the voltage. So it is called as a variable voltage, variable frequency drive. In short, so it is very important for a new entrant to understand, because some customers send you an inquiry saying, do you have inverter drive? You cannot just say that, no, we have only AC drive, so we don't know what is the frequency. So it's very important to know the other terminologies that every industry is quoting. So now, we cannot really understand the drive unless we understand the motors better. After all, it is going to drive a motor. The motors are in two different categories. One is the AC power, another is the DC power motors. So DC motors are slowly moved out of the industry. AC motor has very dominant. Even today, across all the motors of 22 different variants, 90% are squirrel cage induction motors, which the drive is the clear master. Then there are some slip ring induction motor. There are some inverter duty motor for a better efficient running through a VFD. Then synchronous reluctance motors, switch reluctance motors are slowly replacing induction motor in a certain applications. Permanent magnetic AC motors are replacing in a certain application where the efficiency, the speed, and the precision is involved. Servo motors, linear servo motors are taking place in many robotic, special purpose machine, laser plasma machines. They are, completely getting into servos. So there's an overall idea about the type of motors available. Our focus is going to be on the squirrel cage induction motor, which is a 90% or slightly over 90% of what you see in the industrial environment. Now, there are motors. What generally we have is a starters to do, from the beginning. We either start or stop. There are different types of starters. AOL starter, star delta starter, rotor or stator resistant starter for slip ring induction motors, where high starting torques are required. In certain applications in the beginning, of the era, there used to be auto transformer starters seen. Then came a soft starter. And there are certain starters like ponytail motor starters, which is a very big subject to talk. Maybe we can cover it in the series too. Soft starters are, there for a long time, but then still it has not come to a point where it should be used. Wherever there is no need of speed control, it's good to go with the soft starter, which will greatly improve the performance of your performance and life of your mechanical systems. So this is about the starters, but here none of this device would give you control of a speed. What if a car you have and you cannot just don't have an accelerator? You cannot increase or decrease speed. You have to start and stop, start and stop. So how difficult it would be? How a fan without a rheostat? You cannot control the speed. It's very difficult, isn't it? So consider in an industrial environment where you cannot control the speed of a motor. It's earlier there are different speed control methods used other than changing the motor speed. The secondary side, the speed control was changed by using a gearbox, belt, pulleys. There is a very common system in the textile industry is used called VPS, variable pulley system. Means the pulley diameter has a design to continuously change, dynamically. But whenever you reduce the speed on the secondary side, the primary side, you lose the energy. So what you have a system which controls the speed at the same time, don't lose the energy, which can be the energy efficient system. So that's when the VFD started, came into picture. So how VFD works? The AC induction motor speed principle formula is 120 into frequency divided by the standard design of a number of poles, which is like in pair of 2, 4, 6, 8, 12, and then multi-pair pole motors. Now, the number of poles you cannot change. Once it is designed, it is impossible to change. There are dual speed motors and triple speed motors available where a set of windings can change, but again, it is a step speeds. You can have 2 or 3 maximum standard speeds you will be able to. You cannot change the speed linear. You cannot change the speed dynamically. So the VFD plays a major role in controlling speed. How? By changing the frequency. Now, frequency is fixed, is set by your discoms, your power generating companies. You can change the frequency only at the generator level. So how you can do it at a utility level? That's where the VFD comes in. So now you understand why VFD is very popular, because you can change the speed of a motor by changing its frequency at a utility level. Is it only for a speed control? No. So there are various other advantages of a VFD. The key features of a VFD is I just put bullets. It is soft start. The major aspect of a VFD, it gives you a smooth start and smooth stop function. Speed control, energy saving, ease of automation. That is the key of a VFD. Ease of automation. You can change the speed. At the same time, you can change the direction. You can you can introduce a step speed. You can inch. You can do many other aspects of automation without physically do anything. Now, if, for example, you want to change the direction of a motor, you need to change the set of cables on the output, which is a very helpful. Here, you just go change a parameter, it changes. You can put two push buttons, you just switch between 1 and 2, the direction changes. So this is as easy as it is. Then there are multiple protection features which you need to you can have that protection feature, but have many other components to be involved, many other relays and protection circuits to be built, which VFD give by default. We will have a discussion independently on that. Monitoring functions. You can monitor the speed, current, voltage, and many other functions through a display. Then there are application-specific features. For example, you have a lift, so there are lift-specific parameters. You have a crane application, there are crane application parameters. You have a compressor, you have pump, you have you have any application. There are a set of parameters which are application-specific features are there. Then it also helps you bring overall efficiency and performance of a system. Now, having a soft start and soft stop, it increases the life connected along with the motor, which is a motor bearing, the coupling, the gearbox, other linear mechanisms connected in the same shaft of motor. Now, let's come to the topology of a drive. So we know it primarily does the job of converting the frequency from the grid frequency to a variable frequency. So how do we convert? It is a black box. We have a rectifier and we have an inverter. So we first convert three-phase AC in a bridge rectifier into a DC. Then from that DC, we use an IGBT system to convert into a variable voltage and variable frequency. So this is the section of an inverter. This is a section of a rectifier. Now I will explain a bit more in detail. This is a block diagram. So it is not just converter and inverter. So there are some filters, there are some smoothing circuits, or there are some algorithms to control various facts. So it is like 100 factories working inside to give you one simple PWM output as you want. It's a very, very complex system. It's not as 100 factories working inside, 100 logics working behind. You need at least 30 to 45 days of a continuous session topology of the VFD. Now, I will on the design topology. There are two major platforms in the technology side. One is an European topology, another is a Japanese topology. The Europeans drive are primarily the modular design. Everything is an option. It is more for a process industry. It is very well suited for a process industry. Anything which is an optional, you can just plug in. Any other features you need, it is a plugin. In Japanese topology, they are primarily more like an FA product, factory automation product, where it is compact, everything is built in, compact in size, everything is built in. You don't have to really, think once you fix, it's fixed. But you may not get the add-ons as much as you can get from a European topology. So this is a two, dimension of a design topology, European and Japanese. Now, after 2010, Chinese have become very dominant in this. The Chinese have a different, design element to it. What they have done, they have made everything as a OEM, which you will see a practical examples with an image. So it is becoming more and more popular, where European and Japanese have become like a standard, and you have to customize it as a user or a buyer. Now, should you select? So there are various brands, various models available. How do you select a VFD for a particular application? Number one aspect, we need to understand the nameplate. We need to go buy a motor nameplate. Anyone who asks, I need a VFD, please ask the motor nameplate. Okay, so we need to match the full load current of the motor, minimum. Then the voltage class, whether it is a three-phase, whether it is a star or a delta connection, in detail. Then an application, whether it is a normal duty application or a heavy duty application, or a variable torque or a constant torque. These two aspects are very important. What is variable torque? What is constant torque? Any application which is a fan pump where it is not directly driving the load, with generally called as a variable torque loads. Where the motor is directly connected to the load shaft and it is driving the load, it is a constant torque load. Anything other than a standard fan and pump or constant torque or a heavy duty application. Now, from a design point of view, how the variable torque and constant torque drives are designed is purely based on the overload capability. Fans and pumps don't need an overload capability as much as it needs the heavy duty applications. So in a variable torque or a normal duty application, generally the design standards are it will deliver 110% of the overload current mentioned as per the frame size of a drive. In a constant torque heavy duty application, it is generally it is capable of delivering 150% of overload current for 1 minute and 180% for 3 seconds and 200% for any instantaneous requirement of a torque. Now, the other aspects of selection of a drive should be based on the ambient temperature of the environment where the drive is going to be installed. This is very, very important because if you buy an European drive, it is designed for a European standard. There, the temperature doesn't go beyond 30-35 degrees. The same thing you cannot apply here. Here in India, the average temperature in the summer peak, it goes more than 42 degrees. And in industrial environment, where there is the issue of ventilation, the internal safely consider the ambient is more than 45 degrees Celsius. Drive which will withstand 50 degree. If the 11 kilowatt, say 22 amps is a rated current, means that it can deliver 24 amps at 40 degrees Celsius. That is as per the design. If your environment is going to be 45 degree, you need to derate the drive. So every brand has a deration factor. Deration means you reduce the size. How it can capable of deliver. For example, if 11 kilowatt 22 amps at 45 degree and the duration factor is 1% per degree rise, means 40 to 45 is a 5 degrees raised from a design temperature, means a 5% you need to derate. If it is a 22 amps, now at 45 degree, you reduce 5% of 22 amps, means roughly it will deliver 20 amps. In a smaller size, it is okay, it's manageable. But if your drive size becoming bigger, say 200 amps, 300 amps, this percentage of a current becomes very important. Now, what is the solution? How you derate? If you derate by a 5%, 10%, it becomes 7.5 kilowatt. So now, to run 11 kilowatt application at 50 degree, your drive has become a 7.5. So what you should do, how you address this? You need to select one frame higher. Now, 50 degree, 45 degree, 11 kilowatt motor, if the ambient is going to be above 45 degree, you have to select 15 kilowatt of a VFD, which will match the current rating as per the duration factor, which is very, very important. Then another aspect of selection is on the altitude. In India, though, there is no altitude issue. But in certain applications where the why it is a factor, it is mentioned in the catalog, but we generally don't understand why or don't even think about it. Now you are sending certain defense equipment to a Siachen area where the altitude is going very high. So how because the airflow is going to be an issue, it cannot do the heat dissipation. So that is the simple idea of why an altitude matters. Another aspect is on cable distance. So there are applications where the motor to VFD distance, cable distance is higher. The physical distance could be near, but then you need to actually calculate the cable distance, how run the cable is running, through different feeders. If the cable run is more than 100 meter, you need to really consider certain aspects like corona effect and all that takes place, where the output of the VFD is simply more than double at the terminal. It creates a heat, it creates noise, it creates a lot of other factors which will uh, eventually break the insulation of a motor, and uh, probably the cable can get burnt and the motor winding can get burnt. So you need to be very, very careful on the distance between the motor and VFD. If it is above 100 meter, there are filters you need to consider. There are filters like output filter, but again you need to decide based on the number of, the zone. You need to probably put 2, 3, 4 different chokes at a different destination. One is closer to the drive, one is closer to the motor. As distance goes, the selection of a filter also takes place. Then VFD also you need to do it. So this is a very complex selection. We need to work based on the application. Then comes what are the chokes are available. There are 3 chokes, which is AC, DC, output. Input choke, DC choke, output choke. 3 has a very different purpose. AC choke is primarily to protect the input side, and to an extent it reduces the harmonic distortions in the system. Again, it is a very deep subject we need to discuss. DC choke is primarily to reduce the harmonics, which is certain brands supply along with the VFD above certain rating. Smaller rating, it doesn't come with a DC choke. Larger rating, by default, a DC choke comes. You need to specify as the vendor whether the DC choke is built in or not. If it is not, you need to have a DC choke externally. Before connecting a DC choke, you need to also check the selection parameter and other aspects. Then comes an output choke. Output choke is, as I mentioned, it is used where there is a distance issue. Then there are filters, EMI and RFI. Electromagnetic interference, radio frequency interference. Then EMC, electromagnetic compatibility. So there are E1, E2, or a C1, C2, C3 class of filters. By default, you get a C3 or a C4 filters. Now, if your environment is going to have a high sophisticated electronics, you have to have a right kind of a EMI filter, class 1, class 2, E1, E2 type of filters. Again, it is a built-in and sometimes you need to define. Then there is something called the active and passive filter. This is I'll tell you one thing. VFD is a harm to grid. Okay, VFD is a big harm to grid. It is the generator of harmonics, not just a VFD. Any equipment which has got a rectifier, wherever you chop AC into DC, it generates harmonics. What level of a harmonics, what impacts, it is a different topic to address. I'll just touch upon 5th and 7th harmonics is the major harm. 5th generally disturbs the grid, 7th disturbs the system. Means you have a medical, you are supplying this VFD to a hospital where HVAC systems are there. This drive generates harmonics as much as, all the scanners will start working erratically. The display will distort. You will not be able to monitor anything. So there are different methods to address that. One is you need to distribute the power line. It has to, so Joe, electrical equipments which are sensitive to harmonics, you need to separate the line. Then you need to adopt the filters. You need to buy a drives with a good filter. You need to adopt active filters to reduce these harmonics. It's a detailed study on a power quality which we need to work. It's a industry. There are discounts started penalizing customer for harmonic compliances, power quality compliances. Power quality compliance is one, but a harmonic compliance is much more harmful to a grid as well as your equipments. There are other accessories, which is DBUs. Dynamic braking unit, any applications where you need to stop the system much before its inertia, it's going to work on a regen mode and you need to dissipate the energy somewhere. So to do that, you need to have a dynamic braking unit. This DBUs divert those regen energy into a resistor. So right selection of a DBU and a DBR as per the application is very important. Now, if the regen mode is very constant, very intermittent, very frequent, you can use a regenerative braking unit. Instead of you waste those energy, you can connect to the grid. If your system is large and then if your braking cycle is long, you can go for an RBU system. Now, RBUs are coming out with AFEs. So AFE is the next step, which is an active front-end system. Now, AFEs are a parallel drive. You will connect like it's like a two drives working together, and one drive work on a motor, another drive when there is a regen mode, it directly transfer the power to the grid. It works as an energy saving. So, for example, a downhill conveyor where the loading happens at the top and then the unloading happens at the bottom. Now you don't have to apply any energy because the moment you start material in the conveyor is going to just simply come down. This time, the input power to the motor is lesser than the output regen energy. Means it is going to simply work as a generator. Now, how are you going to use this energy? You just connect an RBU and then just divert this energy to the grid. So wherever the motions are in the motor, it will draw the energy from this grid. So it's a very complex design and engineering solution, which needs a lot of selection and engineering for as per the application and then the site condition and then the time duration, how much it is going to regen. So this is a very big subject to work. We can always discuss on this. Now, DBRs, dynamic braking resistor. When you use a DBU, you need to select a DBR. DBR selection is again purely based on the braking cycle, the duration, the braking torque required to be dissipated. Now, not selecting the proper braking resistor, again the system can trip. The DBRs can, achieve its thermal insulation and then it can break away. So every aspect of a selection is very, very important. Now, this is again whatever I explained, it is a bit in detail. I can share this presentation. You can go through in detail, and I'm always available to explain any specific functions are required over a personal call or email. Now comes cable sizing and selection. Now you have a proper VFD selection, but what if you're not selected the cable properly? You need to really size the cable also accordingly. Now, large motors generally has a 6 cables run because you use a star delta starter. Now, using a VFD, you don't need you have to have only 3 cables running. But what size of a cable you need to work on a star or a delta? You need to design different design. So you need to select based on the application. In certain applications, still people use on a star mode where the torque is not an important, but the speed is important. In certain mode where the torque is important, you need to switch to a delta mode of winding. So you need to really go through the nameplate as per the manufacturer and just get these facts checked. If you have a doubt, please don't hesitate to ask the expert. Going by the manual without having a proper knowledge is a big issue. Particularly the star delta selection of a winding is a very, very key aspect of a right performance of a VFD. Now comes to a panel mounting. How are you going to mount the VFD? You need to mount the VFD with a proper, as per the manufacturer, the clearance of all 4 sides is mentioned, means the right amount of airflow should happen. So every drive has a different design of airflow width. So you need to keep the system as suggested by the manufacturer. It varies between manufacturer to manufacturer, model to model, rating to rating. You need to exactly check the particular model, particular rating, particular brand, then decide the panel. You cannot just go by the thumb rule. Now again, you have a cooling fan which is kept in the panel. Again, you need to check where is the inlet and where is an outlet. You cannot ignore this aspect. Segregation and this is another important aspect. If you try to mix the signal cable along with the power cable, it is going to create a nuisance. You are going to have a lose in the signal and multiple drives. Again, the issues are going to be very different. Chokes, I explained. DBU, DBR, I explained. And DBU, DBR is mandatory for any vertical application. You please keep that in mind. Any vertical application like a lift, crane hoist, conveyors, any application where the motion is vertical, the motor should have a brake by default. Your drive should have a brake release logic only after motor. Means you simply open the brake and you start running the motor. If the load is there, if the torque is not available, the gravity is going to pull the whole system down, and it can create an accident. So when you select a VFD for this vertical applications, you need to be very, very, very careful. There are logics available. You need to program. You need to really tune these parameters of releasing the brake only after sufficient torque being generated and the brake is mechanically released. If the brake is not released, and again, if the brake is released and if you don't the torque is not generated, it can create an accident. If the brake is applied, if you start running it, it will create that noise and it can it can trip on an overload. So these aspects we need to be really careful. Then certain cross-section applications where you need to be very careful on textile, wire winding, paper, where the one motor is going to be on motor mode, another motors are going to be on the region mode. So you need to really balance it. Centrifugal applications are again crucial. There is something called a KEB feature, kinetic energy buffering, where the section applications are that this kinetic energy is going to be present. We can use very effectively region can feed the power to the motor which is on motor mode. There is something called multi-motor control through a single VFD. Motors are run by one VFD, the LTs. You need to have a particular motor specific OLR connected in the output. Your selection of a VFD should be the sum higher than the sum of all the motors connected on the output. One aspect on a multiple motor in a single drive configuration is all drive will run at the same time, at same speed and same sequence. So if you need an independent sequence, then you cannot go for a single VFD multi-motor configuration. Now every motor has a different overload protection. So you need to select and size a OLR as per the particular motor on the output of a VFD. You connect 1 HP, 2 HP, 3 HP in a 10 HP drive. So 1 HP motor should have a 1 HP OLR. 3 HP motor should have a 3 HP OLR. It's as simple as that. But all drive output should be connected before you give the run command, and so that the start-stop pattern, acceleration, deceleration happens smoothly. Otherwise, if you switch on the motor after the VFD program on is done, the acceleration is over, it is going to work as a DOL because it has already achieved its full frequency. If you switch on the output contactor after the acceleration is over, it will simply work as a DOL. Now, in a DOL, it is going to draw 6.5 to 7 times the rated current. Now, 6.5, 7 times rated current is going to be an overload for a VFD, and VFD will trip output motor overload. And it is going to create a lot of other issues. So, on a multi-motor configuration, you need to be very careful. Now, single motor also works on a multiple drive, where the motor size is large, where you need to use two different drives to couple the power section and then run it. It is possible, but it is generally done at the OEM level. two parallel power sections are merged and single control systems are given. So that is a paralleling of a drive. The you need to filter. There are a lot of aspects on a parallel of a drive. Sequence operation of equipments, utility equipments. Like for example, in pumps, you have three pumps. One pump is always on a standby. What if you don't use the pump for more than a week? It gets jammed. So you need to sequentially use pump one, pump two, pump three. So whatever is available on the standby used on the second time, the third time would work on a standby. So it is like on a sequence. Every 8 hours you can change that. So that features are available as a programming feature in VFD, which is particularly designed for a pump or a sequence operation like this. Or you have to have an external controller to do that. These features are nowadays built in with the VFD. Now, as I said, the load distribution is very important within the panel. I have seen in many cases where all the VFD panels are given to one side and the other TCC MCs are on the new feeder. Now, the maximum load is going to be on this feeder, which is going to create an issue on the load distribution system. So, while you design at a plant level, or particularly on the process industry, we need to really take care of this aspect where you need to distribute the load equally and even. So there are consultants who can help you on that. Anytime you need any support, we can always help you. So these are all about the selection and engineering we discussed. Now we go with the control method. Now a VFD, as I said, we are changing the frequency. How we change by converting into a DC, then again putting back into AC. So now there are control methods available. We are now, as I said, V by F, we are changing voltage as well as the frequency. Now, changing voltage and frequency, there is a pattern. You cannot just simply change, how you want. So there is a pattern they are given. The V by F ratio should be maintained constant. Means now you change the frequency, you want to reduce the speed to 50%. So you reduce the frequency from 50 Hertz to 25 Hertz. Now, if you change the frequency, if you apply the voltage, if you, for instance, you consider you are not changing the voltage. Now the voltage is 400, but the frequency is 25 Hertz. What happened? The flux going to be there is going to be enormous. And it can create an overheat issue. So you need to reduce the voltage also to the same ratio of frequency. 50% if you reduce voltage, also you reduce it to 50%, which is 200 volt on a 400 volt system. So 200 voltage and the frequency is 25. The ratio is 8. This is the V by F ratio. This ratio we need to maintain constantly. You don't have to do it. The algorithm does this job. It will be maintained across from 0.5 Hertz to 50 Hertz. Beyond 50 Hertz, if you are in VFD, you can change the frequency above 50 Hertz also. You can increase the speed from the rated speed, but you have to be careful. The motors and the mechanical systems are designed to withstand a certain speed. If you go beyond that, it can create a damage to the mechanical system. The bearings can or not break out. Now, how much you can go, depends on the application. Now, when you go beyond the rated speed, the torque comes down. You will achieve speed, but you will not achieve a torque required by the application. So you need to balance this act. There are different algorithms to use for different applications. You can check. The basic V by F control is one. Now, V by F control is just by an algorithm. It doesn't have a feedback. So drive works blindly and sets its output. Now, what if you give a feedback to the system? It can improve certain performance. I will tell you what are the performance change between the different control methods in the next slide. I'll just brief out what is V by F. Next is a V by F control with encoder feedback you give from the motor. Third one is open loop vector control or a sensorless vector control. Means you try to understand the motor model in a much better way by doing an auto tuning. your drive gets a mathematical model of a motor by doing certain tuning function. In general, in VBIF, you feed the motor data. You could be wrong, or you would feed few data which is available on the nameplate. In open loop method, by doing or during auto tuning, you will be able to uh, uh, gauge all the parameters of a motor, not just the kilowatt and rating, but what is the load current, what is going to be the line current, what is going to be the ion coefficient, saturation factors. There are 18 to 22 parameters which drive will try to read by injecting certain voltage and frequency and analyze it, and it does the mathematical modeling of a motor. Now, you may have to do this tuning 2 or 3 times. If it is a new motor, first time you are going to do it for 3, 4 times, because it is cold mode. You need to warm up a bit and then start doing it because the parameters changes drastically when the motor comes to ambient temperature. So you need to do a tuning when the motor is cold to a warm, and do it 3, 4 times. It takes the average and then the best of a result comes out. Once the during the tuning, the motor has to be idle. Means it should not be connected with any of the loads. No gearbox, no bells, nothing. It has to be just tuning is not possible. So there are two type of a tuning is available. One is a dynamic auto tuning, another is a static auto tuning. In the dynamic auto tuning, uh, it gives a much better result. I can explain that factor later how it is done. Now you cannot disengage these aspects, so you can just do the basic auto tuning where the motor shaft don't turn. It will just heat up the system and then see certain parameter. It injects certain voltage and then see some how is the return current is. Accordingly, it develops its mathematical model. Now, the other control method is called a advanced flex vector control or a closed loop vector control. This method is open loop control method with feedback. That is the advanced flex vector control mode. Means if you do the tuning, you also give a feedback. So this is the parameters are going to be very different, unique, and you can set as per your application. You need to tune it more cohesively to set the application demand. The premium of application on the control method is a patent technology of ABB called the direct torque control. This feature is the epitome of control method. It works like a magic in applications like a paper, textile, tension web-based application. This is the maximum feature used, and there are certain brands has a different terminology to call this. Parker, ABB, Emertron, Siemens are very popular in these control technique for that matter. They are very useful in this control method. So these are the 5 different control methods available. Now, for example, you wanted to do a feedback to the VBIF with PG, second option. Your drive also should have a facility to read the encoder feedback. So generally, standard drives don't come with that option. You need to buy an encoder feedback card. Closed loop function or a advanced closed loop vector control. Again, you need to buy the encoder feedback card. You need to have an encoder. What type of encoder? There are 6 or 7 different types of encoder based on its output. You need to analyze that and then buy a card accordingly. You get an encoder card and choose an encoder according to that. Forms. All different control methods gives 3 aspects of change in the system. One is it influences the speed control range, speed control resolution, and speed control response. These are the 3 aspects or objective of selecting a proper control method. Let's come one by one. What is speed control range? What is the minimum speed, maximum speed you can achieve? minimum speed achievement is very important, which is decided by the speed control method. Now, in a V by F method, minimum to maximum speed is a 1:40 ratio. Means if your rated RPM is 1440, uh, you just divide it by 40. So what is coming, say 35 RPM? 35 RPM is the minimum RPM you can achieve. Below that, you cannot achieve. Now, not just achieving the speed, also achieving the required 100% torque at that RPM, which is the aspect. Getting the sufficient torque at 35 RPM is a very difficult task to achieve. Now, you want to reduce and get a better performance much lower than 35, then you have to tune the system. You auto tune, so you go for a open loop sensorless vector control mode.
ठीक है
Control
नेक्स्ट
the RPM as low as 14.5 RPM. Means you will achieve the required torque at as low as 15 RPM also. When you do a dynamic auto tuning, it does the rotation, it knows motor parameter much better than the static auto tuner. So it gives you a better performance in terms of the speed control range. Now, in an open loop vector control, you get a maximum speed range of 1:1000. Again, it is just for a reference I gave. It varies between manufacturer to manufacturer and software to software. Now, when you run at 1:1000 means 1.5 RPM, you will be able to control the motor and deliver the torque at the same time. So now you understand why selecting a particular control method is very important. When your application is demanding a low speed, high torque, continuous operation, you need to go for a closed loop method. You need to buy an encoder. You need to tune it. You need to adjust certain parameters to achieve that range. Now, achieving range is the one aspect. Another aspect is the resolution. Means we are trying to achieve, but how accurate they are. In a V/F method, the accuracy is very poor compared to what you can achieve in the closed loop method. Means is it could be as poor as 0.5%, 1%, 2%, depends on the software function, depends on the algorithm what they have created, depends on the programming you do, and also the other aspects of selection and engineering. In a closed loop application, you get much better. In a servo application, you get much better. The speed control range in a servo application, it is considered as a 1:5000. Means you can control within a RPM within a degree. You can just move a motor 1 degree, carrying full load, full torque, and stop within that 1 degree. The acceleration takes place. Run command you get, you move, you stop at 1 degree. All happens within 1 degree. So that is the precision you can achieve in a servo motor. The main difference between servo drive and AC drive is almost same. The game changes because of the motor, because they are permanent magnet, high precision motors. And the drive has a built-in many functions, built-in encoder, very high resolution encoders. You have a 1 million pulse per revolution encoder, which is a different technology altogether. Now the market encoders, you get a standard encoder, you get is like say 10,000 pulse per revolution is the maximum you get. In servo, you get 1 million PPR, 23-bit, 21-bit, 17-bit, 16-bit, 13-bit. These are all the popular encoder spec which you get in the servo system. Now it is not just about the pulse per revolution. It is also about how well your algorithm works. Aspect of advantage of a control method is response. How dynamically it adapts to the speed you ask the VFD to go. Motor has to adapt to the speed. In a basic control method, it takes time. In an advanced control method, it works fast. Motor dynamics are going to be same, but the way the drive is going to dynamically change is going to change in the advanced control method. So it is how fast it changes. Now you in a car, you press an accelerator. Okay. What if it takes longer time to go to the speed? Means the command is given, but then it takes time to react. In advanced, same in VFD, in advanced control method, the response is going to be very quick. So drive is going to give very quick command in change of parameters like voltage, current, and all that. Whatever the aspects it is delivering to the motor, it is going to dynamically change that. So this is what you achieve by adopting to a better control method. Speed control range, speed control resolution, speed control response. So the key is knowing the motor mathematical model. Now let's come to protection and monitoring functions. Now, what are the protection and standard VFD gives? It protects the system from low voltage, high voltage, voltage imbalance, voltage fluctuations. All this it trips. Under voltage, over voltage, imbalance, voltage fluctuation. Imbalance is within three phase, two phases are 400, another phase to phase are like 280, 300, 340. That is the imbalance. Fluctuation is it is a fluctuation fluctuating between 300 to 400. There are certain tolerance given. So if it is fluctuating beyond that tolerance, it trips. You cannot disable this aspect. A star delta starter, DOL starter, conventional starters, doesn't have a protection for this. It runs. So many cases, what happen in the rural site where the power quality is poor or at the peak time. So there is always the issue that say sir, your VFD stripping, our other motor is running because other motor doesn't have any sensor. It doesn't sense any of the voltage parameters, so it runs. You cannot compare it with an electronic device, which is a VFD. It senses everything. Some customers find this is a nuisance strip, but it is to protect the system, so they need to work hard to address the electrical parameters. Number two is a thermal. It trips on overheat. You need to set a thermistor, motor, inverter, IGBT overheat. All this independent heating can be sensed, and inverter overheat, IGBT overheat is sensed inside. Motor overheat, you need to give external. And there are PT sensors available. PT interface is also available in a drive. The external PT interface also you can give direct. Then current. Overcurrent, it trip. Undercurrent, it can trip. If current is hunting, it can trip. Limits, you can set a higher limit, lower limit of a current. You can also do a torque setting. Beyond a certain torque or below a certain torque, the system should trip. It can do that. Again, we need to program, define, select a model. Not every drive will give all the features. Undercurrent trip is required in many of the pump application. We need to enable this aspect because dry run of a pump is running, but then water is not coming. Pump will burn within 20 minutes. So the undercurrent trip is to be tuned in such application. I'm giving certain examples. This is a very, very vast industry. Within 1 hour, covering the whole aspects is a task. So I'm just trying to give just a glimpse of what is what. Overload, motor overload or inverter overload. Certain parameters it will sense, and then it trips on a condition-based tripping on overload. Now, how drive trips? It purely measures the current. Okay, all the trip is purely based on the current sensing. Now, current, if it is the drawn current is 500 percentage or 5 times the rated current within 3 seconds. If it is drawing, it will consider that probably the motor winding is lost. Motor winding is burned. The output short circuit. If the percentage is 200 percentage in 10 seconds, then it thinks that probably the inverter is overload or cable is open. There are conditions based on the current sensing, how much current, duration. Based on that, this logic works. And then there are other algorithms inside. It has got its intelligence to decide and show you the error code. What could be the possible error? It could be different from make to make, model to model. Overspeed and speed mismatch. This you can achieve only when you have a feedback system. Means you need to have a closed loop system. You need to have an encoder. You need to set the limits. Then it can protect you from the overspeed and the speed mismatch. Particularly in a test bench, these features are very usable. Train system, hoist over speed, you need to protect. Other it is considered as a free fall, means a brake failure or some other issue. So you need to protect the system. So you need to have influence customers understanding of, if you know that this is very critical, you need to tell the customer they need to go for a closed loop method. They need to have an encoder. They need to enable this feature. There are certain features on board. There are certain features available for you to use based on the application demand. Customer is not going to tell you. You need to select and recommend to the customer or a user. You need to tell the people to utilize that feature. Then there are system protection features and then software protection features are available, which will say that a control card error, maybe the version error, sometimes it happens. You can do external fault simulation, external fault integration. Now, which is like you are probing the system. You have to create external fault inputs. Say if a particular motor is off, this system should be shut off. So you need to take the NONC of that drive and then give the run command through that, or give some status input. It can be sequential. It can be independent. You can set certain process input sequence also. For example, when this level is achieved, your VFD should stop. When the temperature is achieved, this should stop or this should start. All that you can program. You can integrate that with the PLC, DCS, HMI, or any of your field instruments. You can change it based on your all analog inputs and control inputs, whatever you have. Now comes the monitoring functions. The general starters don't give this. You need to buy MFMs to achieve this. You can monitor the current. Could be a full load current, no load current, voltage, input, DC, output. All three you can check. Speed reference you can check. Input frequency, output frequency, input speed, output speed. These are all theoretical values. You can calibrate to a certain point. This cannot be a very accurate view, but just for continuous monitoring, these aspects are good. You can also monitor the IO status. Every drive has such a number of DIDOs. So this IO status also you can monitor, like in a particular break sequences on, off, how many times it was on, off, all that you can check. And all this data can be viewed through PC suite softwares also. You can take this data. These data are available in a certain directory within the protocol given. You can do the data logging, connecting through the communication port. All this data can be dynamically monitored through a PLC. There are more protections, more monitoring functions available. I recommend all of you to read the manual. Reading the manual is one of the best thing. I have a habit. Read the manual completely. It will open up a lot of avenues for us. Certain features are given, so you try to understand how it feature works, how it is. It can be practically implemented. So key is to read the manual. Now, these are the general parameter sets you can do. Run mode. Now, how are you going to run the VFD? So you have to connect to the VFD, you connect to the motor, you are selected properly, sizing done, everything is done. Now, there are some features you can give, which is you can run the motor just by in the keypad on off, forward, reverse direction, you can select just on the keypad. Now, keypad, generally what happens, there are issues that operator can damage that. Continuous usage of a keypad can probably damage the system. So people go for a terminal, means a push button. So you can take out the on-off condition to a terminal. You can also do it through a PLC. So this you need to define first, how I am going to run the VFD. Now, second aspect is speed command. How are you going to change the speed? You can change the frequency by changing from keypad. Go to a particular directory, change the parameter and set, it will adopt. There is a built-in potentiometer given in smaller VFDs. You can just configure that, and then you can just use it like your electronic fan dimmer. You can just change the speed of a motor by using that knob. Uh, there is a built-in port. If the built-in options are not there, you can use an external potentiometer. Again, you need to be very clear in connecting that which point to connect. You know, by wrong connections, you can damage the control card. So you have to be very careful on using that external port. Which terminal, what wire to be connected is it should be very careful. You can there is another feature called up down. You know, two push buttons are given. If you constantly press up, the speed goes up. If you constantly press down key, it can reduce the speed. So this feature is also available in certain application. You can configure it. Then through a PLC, what are the you need to set the drive basic parameters: the kilowatt, full load current, normal duty or heavy duty, voltage class, acceleration time, deceleration time. So this is very important. This is the basic parameter which you need to set. Without setting that, there is always a default parameter which may not be solve the purpose for you in a given environment. So you need to change that parameter from factory default to a user requirement. Now, once you set the drive parameters, you need to now set the motor parameters. Motor parameters like a kilowatt, full load current, number of a pole, base frequency, minimum maximum frequency, all that you can set. Then if you do the auto tuning, it will collect more data. And then go for a control method selection, control method tuning. Then you have to configure the digital inputs. Here it is called as a multi-function inputs. Means this is a user definable. So there are some 60, 70 options given for each terminal. You can define what you want. You want a start stop, you jog, you want a reset, you want an external fault, you want a step speed, you want a brake open, brake release. Like what are the options available for you for a particular model and a particular make? You can choose within the choices given to you. So in general, you get 5 digital inputs, 4 digital inputs as a minimum from any basic drive. Out of that, 1 or 2 are generally defined for a run or a stop or a forward or reverse. So you have a 2 or 3 external inputs. You can use step speeds, you can use jog in. So I recommend you can go through the manual for a very detailed understanding of these aspects. Same way, input, you have outputs. So multifunction outputs. Again, this is a user definable. This is again a status condition, on or off or a fault, all that you can explore. This is fault output. You can give the status of a VFD run, VFD off. You can integrate this to another VFD run command. You know, all that is possible. Brake release, you can use it. Then comes an analog input. So now, if we are going to run the speed through an external port, you need an analog input. So there is a source available within the drive, 10-volt source is given to you. So you can take that and give as an analog input through the potentiometer to the analog input terminal, which is the point where you give the frequency command, speed change command. It can be a 0 to 10 volt, it can be a minus 10 to 10, 4 to 20 or 0 to 20. So 4 to 20, 0 to 20 where you have a distance issue, PLC or a DCS input you're going to give, you use the current because there is no drop in the signal. So if it is within the machine in a closed system, you can use voltage. Longer system, you go for a current signal. You have to define what is going to be your speed reference input. You need to define then accordingly because drive is blind. Use default setting is there, say 0 to 10 volt. If you are going to give current, it is not going to recognize. So you need to define that, otherwise drive is blind. Now drive also gives you an analog output, 0 to 10 volt. This output is primarily for a monitoring. It can give the equivalent correspondence output to in respect to a speed or a frequency or a output current or a torque. So this you can define, or not every brand gives, but then certain brands, advanced models gives a torque output also. So you can choose whether you really need a torque output, then you need to select the VFD and a lag output accordingly. So these are all certain aspects of a general parameter setting. So these parameters are grouped. Every group you need to go to that and then set all the parameters, change it from a default value. There is always a default value. You need to enable or disable or set to your desirable value. Unless you don't set, it is going to take a factory default. The factory default in general, uh, considering the safety and all aspects, it is good, but still you need to be extra careful for your application. You need to choose what is right. So don't ignore with a few parameters set and motor starts running. Okay, motor is chalo. It started and why I should bother. No, you need to go through every aspect and ensure all the parameters are set as per the application demand, not just by the factory default. There are application specific parameters available as an application macros in some brands, and then some brands it is a set separate parameters. You need to go physically and then set all that, like a lift, crane, winding, pump, S curves, U curve, carrier frequency you can change. Sorry, it is not carrier. There is a spelling mistake. I changed. Speed search you can do. Motor tools, special motor selections you can set two motor parameters within the same drive and you can sequentially operate. Now, for example, you have an 11 kilowatt drive. You have two motors to run, two pump. At the peak load, you run a 10 HP pump, and then low peak, you run only 3 HP pump. So now you don't have to buy a two VFD to run that. You can use the same VFD, set motor to parameter in that, and select a logic in which you can choose a motor too when you are going to run a 3 HP motor. That parameter it will catch and run. So here you can intelligently use your resources. There are special motors you need to tune. Then DBU DBR is recommended, but then you need to set the parameters, set the limits. You have to enable it. By default, it is not enabled. You need to enable. So you have to select a proper starting method and stopping method. There are different starting method, like a stopping method, like coast to stop means you are allowing the motor to stop on its own. Means it will take a lot of inertia to stop. So if your application demands an immediate stop, you need to use a deceleration to stop, which is a standard feature used. Now you wanted to, when you stop at deceleration to stop, it will trip off a over voltage because you are trying to stop the motor before the inertia is over. It is going to pump back the voltage to the system and the drive will trip under over voltage. To do that, two things, you have to increase the deceleration time, or you have to install DBU DBR. Drives up to 15 kilowatt or 18.5 kilowatt has a default built-in dynamic braking unit. Above that, you need to buy an external DBU. DBR, you need to buy externally and connect it externally. Then there are energy optimization features you can use for an energy saving application. Acceleration, deceleration patterns are available. You can use it for a different application. There are very detailed communication parameters group, firmware and software versions, and clear fault group. And you can watch the fault codes. What the trend of a fault, what are all the faults happen so far. You can see. It is a big log. You can log in and then see what is the particular fault and what was the issue, what caused that fault, what is the remedy. So you can follow and then do the troubleshooting. It's very detailed. You can go through the manual and it will definitely give you a lot of views about VFD. You don't need any session. You read the manual for say 10-15 days. You will know most of the features, whatever I explained. You try to just Google, YouTube. You will know more data than what I have explained you today. Now, what are the basic components? I'll just run through. Uh, uh, Control board, interface boards, gate driver section. In the power section, converter and inverter sections, there are diode boards. There are SCS thyristor transistors. This is how the evolution came. Now it's mostly IGBTs or IPMs. The capacitors used one are power capacitors, then are smoothing capacitors. Cooling fans are very important. Keypad and integration board. Again, you have a choice of LED keypad, LCD keypad, keypad with the potentiometer. Terminals, power terminals are large and you please connect earth. Without connecting the earth is a big issue. You have to connect the proper earth. Earthing is one of the major thing you need to really be careful. Output, you cannot be wrong in connecting input in the output. In cases I have found they are connected wrongly. So you need to really be careful on input and output connection. You cannot connect output to the input. So you go through the manual, check where RYB has to be given. Mostly all the drive comes as a RST. Okay, we have a habit of RYB. So you check and then connect it. A DC bus, people have connected DBR on a DC bus. So DBR connection is defined in a particular place. Accordingly, you need to connect. You cannot just connect in plus minus. Be very careful on that. So go through the manual. Then a control IOs. It is given in some cases. I will show you some pictures. You can get an idea. Filters, DC choke, EMI filters. Option cards like IO extension cards. You need more IOs, you can buy an extension card. You need a Profibus or a Ethernet cards. By default, it comes as a Modbus, most of the drive. If you need with the Profibus, Profinet, Ethernet, EtherCAT, Mechatronics, all that options are available as a protocol option card. You need to check what is available from particular brand. Some brands don't have an option card, then you need to change the brand. PG feedback card, pulse generator, encoder feedback cards. And just to give you a few picture for a reference. So this is a power section board. You can see the terminal is given here. And this is the control interface, the white color where a ribbon cable comes. So this is a power board of say 5 HP drive. It changes between brand to brand. And this is the control section board. And you can see these are the control IOs. Ethernet port. This is a fault output relay. This is a keypad indicator, and this is a keypad toggle switch. So drive keypad sits on that, and there is the switch inside. So when you press it, it goes inside. This is a toggle switch. So this is how the control card is there, and it is an overview. Power board. You can see this. This is the IGBT. This is actually it's called as a tubular IGBT or FX. This is the inside view of a VFD. The power section, power board, control board, power terminal, cooling fan, control terminal, communication terminal, and a keypad option. This is the other side of a view. This is a capacitor bank. This is an IP65 drive. You can see a power board, control board, capacitor, everything is a single board. And a housing and a projected heatsink. And terminals are plug-in. You cannot wire, you have to just plug in. So what is the next generation drives are in demand? It's going to be decentralized power section, thus it has become a modular. Use of a nanotechnology, so it is becoming compact and compact. IIoT and Industry 4 features are built in. So you can do remote monitoring everything now just by connecting a VFD. It is becoming more and more energy efficient. More advanced control performance are there. 40, 50 years, there is no change in the motor. AC induction motors came in picture in 40s, 50s. Even now, the same induction motors are being used. It has just become more energy efficient by introducing IE2, IE3, IE4. But in terms of a design or construction, it is still the same. So now the other technology parallelly coming or a PMAC, BLDC, SRM, SYRM type of a motor. Now your VFD should be able to drive these motors. So it is a control feature, algorithms. So your motor are changing, the drive is also constantly changing. The modern drives are able to run without any change. Power quality norms are getting stringent. So the drives also coming in with a lot of options to cut down that. Direct AC to AC conversion models have come, so which will greatly reduce the harmonics related issue. Commercially, it is still not viable. Improved safety norms, application of process specific drive, OEM designs. Now, drives started designing, manufacturers started designing VFD based on the applications and the customer demand. Motor integrated solutions, superior engineering. So this is what you saw. This is a superior engineering solution. What are the dedicated design drive which has already occupied the market, which we one is the integrated elevator drive. So now whatever the lifts are coming has a better performance. Now go for this IED. Means earlier the lift controller is an independent thing and VFD was independent. Then all the cords are independent. Now what you see on the picture is one control panel, which is a VFD plus controller plus IO interface plus auto rescue device plus interface for a lift operator panel, core operator panel, then ability to run a permanent magnet motor, annunciation system, display system. Also, it has a remote communication mode available, GPS, GPR, and all that is available. Means you just buy this connected, like your entire lift, you can monitor from anywhere. It same thing is happening on the injection molding machine, where the motor is changed to a servo motor, drive, controller, interface, everything is built in. Then a dedicated crane control system where the drive plus ease of integration plus some additional safety features are built in. Compressor control systems have come, which has got a controller plus drive plus IoT and the remote monitoring and alarm. Solar pump control system, which has come. So this is a so for a solar application means from a direct solar DX connector, you can directly plug in, and the motor you just connect it. It is done. It is an IP65. All the features are built in. I will explain you here. So this is specially designed for a solar pump application. Design is unique, direct plug and play, ability to run any type of a motor, wake up and sleep function, pump, dry run, other features are built in. Now, modular drive, there is one. You can see these are all independent drive, compact, still it is larger. Now the new designs have come. You can see it's a 6 or 8 drives you can connect in a single power pack. What input is only 3. You can see every module is independent module like a PLC IO module. Only the output is there, UVW. You can just plug in the motor. Now programming is common. So you can select whether it is a drive 1, drive 2 by name called axis 1, axis 2, axis 3. You can set a parameter for a particular motor. It reduces the space. This is how it works. It's a more detailed picture. Now, the last slide is about the market share. You know, all said and done, you need to understand who is doing how much. ABB is the market leader in this segment, followed by Siemens, Danfoss, Japan, Delta, CG. You know, these are the most popular brands in India. The figures are of 2022. So now, thank you. You saw maybe 12, 15 brands in the chart. You know how many drives are there? 122 known brands in the market. 122. I don't think any product has this much of a competition. Now, so there is a market available. You saw there is a competition. You saw. So the potential, this market is growing about 14% every year. 14% is the growth. 14% is the growth. Now, the potential to disrupt particularly in the Indian environment, is 9:1 is the ratio. Means in US the ratio is 2:1 or 1.5:1. Means almost every motor is practically driven by a VFD in advanced economies like Japan, Europe, and US. But in India, it is 9:1. Actual data is 11:1, removing some applications where there is no need. So I am not considering that. Even otherwise, on an industrial environment, it is a 9:1. Even if we improve 7:1, we have 9,000 crore market available to address. So thank you very much. Sorry, I just took more time. I hope this is session is informative, and we can have a very detailed session whenever it is demanded. We can discuss in detail. You're all welcome to share your inputs, and I'll invite Mr. Gurmeet sir to formally close the session.
That was a wonderful session, Vijay, and very in-depth, and you have great knowledge on this subject of VFDs. And
Sir.
I don't think one session can cover it in depth, but you have done a good job. Maybe
you, sir.
depending upon the interest of participants, we can also organize in future another session on detailed, applications and the do's and don'ts while using drives. We'll take a few questions.
Yes, sir. I am seeing the chat window.
So, anybody would like to? Of course, there are questions in the chat box.
Yes, there is a question. There are a few questions. Few people have answered also in the group. There are. Does VFD can act as a replacement for starter? Yes, when you use a VFD, you don't have to use a DOL starter, but you have to ask whether you need a VFD, whether you need a speed control.
Yeah. Many questions are answered. Rajshekhar answered why altitude matters for a VFD. So air is rarer as we go. For example, a drive in high altitudes may require external raining training. Okay. Signal lines, of course, should be kept separate. I myself face problems where my equipment, where the lines were laid by the customer along with the VFD lines, and they used to complain our signals are not coming, not being displayed on your equipment properly. We found it was a noise problem. So them to separate, install filters, and then it worked.
There is a question of calculation. Can you brief us regarding switchgear selection for a VFD?
Yes.
It is about input can be SFU or MCB, MCCB based on the current, and on the output it should be directly given to the motor. If you are connecting a contactor in the output, you need to ensure that contactor is latched before you give the run command from the VFD. Then semiconductor fuses are mandatory. I recommend customer has a budget or not. I say that I cannot ignore this, but semiconductor fuses are recommended. Then some questions. The question by Mr. Sanjay Mishra is on the VFD for HVAC application. Primarily the HVAC industry is a parallel industry, and the general industrial VFDs are not used. Primarily on one aspect, they ask something called a fire retardant. Okay, the component of the VFD should be certified and comply to that standard. Then a communication protocol with the BMS, that is like Apogee, LANworks, all that feature is required, which general industrial drive doesn't have. The most important fact is something called emergency operation of a pump. In general, what happens when there is a power failure, the all systems shuts down. But pump in a HVAC industry should run if there is a fire interference. So the drive should have a featured, if there is a fire incident, it should not trip, it should run continuously. So these are the three major aspects. Apart from that, it is purely driven by consultant, and then consultant have very specific brand, and then only those drives are going in.
Right.
Then there are VFD has become a market commodity. I have also mentioned in the thing, but then it is not as even general commodity like a contactor. Still, people don't select the cable and contactor properly. So industrial product, and for example, I'll tell you in the society in our house, we should have a ELCB, RCCB installed in our panel board. Every people today who attend the session, please ensure your house DB has a RCCB or a ELCB precisely. It will protect you from many aspects. Like for example, a heater is a major thing which can probably transfer the shock to you when you take a shower. So please ensure RCB is installed. Likewise, things can become commoditized, but then we need to follow the basics. Just it is available by price, lowest. You please don't just simply don't go. There is some question is asked about VSI, CSI. Uh, Basically a voltage fed system and a current fed system. That is actually a VSI and CSI. Current source input, voltage source input. This is the technology of 80 to 84. Can VFD use for non-motor application like it? No, VFD is primarily for induction load and only for induction motor, squirrel cage induction motor. There are inverter duty motors available. You can use that, but for a heater, it is not recommended. You certain application they use the VFD, but you need to take care of a lot of aspects. I can personally suggest how you can use this for a induction heating application. Such. So most of the questions are asked. Any open questions? I can answer now.
Hello, sir. This is Srinivas. Hello.
Yes, sir.
Actually, sir, in a practical way, what is the voltage source inverter and what is the current source inverter, sir? Some people are saying in a voltage source inverter only the filter capacitors, electrolytic capacitors are there, na? That is DC bus section. If in that DC bus section, if there is a L filter, means without capacitor, then it can call as a CSI. Is it right?
We need to work on the architecture of a drive, and then I can tell you whether it is a VSI or CSI. In some cases, it is both. Certain inputs are because there are 12 sensors available to sense both voltage and current, and inputs also given from both sides. So looking at the architecture, I can explain you more clearly what you can decide. Today, as a user, we have a very limited choice to make, and then whatever is available, we can take it.
Yes, sir. Actually, practically, I didn't see, sir, the current source inverter. And normally, I have gone through many VFDs and application, different foreign, Europe and Japan standards also. I worked already presently and also working. And I have mostly noticed only voltage source inverter.
CSI is a common one which is used, but actually there is a small element of a CSI also in all the drives.
Okay.
But
sir.
how they
Okay.
build the algorithm, that we need to check. And there is one more question, very 18 pulse VFD. Sir, 6 pulse and 12 pulse are common in LVD, and 12 pulse very few brands have got. 18 pulse you need to have a different transformer. In a medium voltage application, 18 pulse, 24 pulse, 36 pulse are quite common. I can explain you what kind of a design you need to have to address that. You need a very special design track to use. Every 6 pulse, every section as a 6 pulse, you need to have a power input.
Yeah.
Yes. Thank you, everyone. And
I think, friends, yeah, we have exceeded time limit as per norms, and thank you for your patience also. As a seminar webinar has gone on for at least we have taken an hour, half an hour or more of your time. I would request you. This is of course a very interesting topic and very technically and elaborately taken by Vijay. You can reach out to him. His email is there on the last slide. And you can also reach out to him through ISA because he's a secretary. Our email ID is info@isa-pune.org. We welcome your participation and suggestions and look forward to your interest in ISA and look forward you to joining us at, you can join us at isa.org very easily online, or you can contact us if there is a problem with the foreign credit card payment or something. We can arrange to do this in INR. Thank you so much.
Yeah,
And
thank you, everyone.
thank you all the participants for taking out your valuable time. Thank you, Vijay, for such a elaborate session. And we look forward to more such sessions in the future. We are starting a series of back to the basics sessions in technology, where we're going to cover sensors, measurement, analytical, and so on at the field level. And I think this will interest a lot of participants. We look forward to your presence in that time. Thank you so much.
Thank you, everyone.
Thank you, sir. No, no.